Good. Okay, question 10 says solve the following logarithmic equation. So the question I kept asking you yesterday is it a single logarithm? Do you see a single log in there? Yes or no? Yeah. Yes. If you do see a single log, then change it to its exponential form. Something to the something power equals something else. What's the base? 4. The exponent? 2. The argument that it equals? The last thing in the list. Shouldn't be that hard of a question to answer now. What do you think? 16. Done with that question. Move on to question 11. Now I notice in this one it says be sure to reject any value that is in the domain. Okay, I see that it says that same thing in the last question. The only types of values that you need to truly worry about for now would be negative numbers. Negative numbers. Okay, and that has everything to do with not being in the domain of that function. But if that's a single log in number 11, switch it to its exponential form and solve it. Okay, so if it was a single logarithm, what did you change it into?
4 to the negative second equals x.
All right, so what is that? 1 over what? 1 over 16 is the correct answer. Thank you very much. Is there anybody out there in TV land that did some sort of decimal form? Anybody? I mean, I would accept that as well. It sounds like nobody did this. Typed it on the calculator. All right. 0.062. Was there a 5 somewhere in there?
0.065. Yeah.
Ah, okay. I thought so. I know. You just rounded it off. It's okay. It's okay. I just thought there might be a 5 in there somewhere. Okay. What about that? Is that a single log?
Yep.
Okay, so rewrite it in its other form. You got base exponent equals something. All right, let's go, Mr. Werewolf. What's the base? Tell me when you look at this what the base is. That's 16, right? That's that little subscript. Mr. Prendle, what about my exponent?
1/4.
1/4. That leaves one thing left to fill in there. 16 to the 1/4. You probably should all know what that is. You probably would know it better as the, what kind of root of 16? The 4th root, right? And what is that? 2, that's right. All right, so 4 to the negative 4th equals x minus 4. What do you get? 4 to the negative 4th, that's like 1 over 256. How do you solve this? By adding 4. So your answer would be what? 4 and what? If you wrote it as a fraction, how about a mixed one? Well, is it like 4 and 1/8? Is it 4 and 1/2? What is it? Yeah, 4 and 1 over 256. Okay. Yes, you can do it as a decimal, but it's going to be some weird. I mean, 1 over 256 is kind of small.
If you added 4, it would be 8.
No, they're not the same exponent because this is 4 to the first.
Oh.
Okay, and that's 4 to the negative fourth. So one is equal to, 4, and the other one is a really, really small value. And so, but they're both positive, so you're adding them together, so you get a little bit more than 4. Not a lot more than 4, but you get a little bit more than 4. Okay, so they're getting a little bit more intense, not like too terribly difficult, but it's still a single logarithm, right? So, change it to its exponential form. Something to the something power equals something. What's on the other side? I should say we got a 2 for the base. What's my exponent? 2 for the exponent. That's true. That leaves me with 3x plus 6. Should take you all of about 30 seconds to figure that one out. 4, if you take away 6, that gives us 3x. That would be negative 2 over 3, right? When you divide both sides by 3. Okay. Is this a single logarithm? No, it's not. Now, depending on how this goes, this might be an extra credit question. I don't want to get too complicated with some of these. We'll see how this one goes. What am I supposed to do with the x and the 7x minus 1 to make a single logarithm?
Distribute.
Multiply them together, which does cause distributing amongst that. So, not wrong answers there because this will get distributed to both of those. So that gives me 7x squared minus x equals 1. Now we have a single logarithm. So if I rewrite that in its exponential form, something to the something power equals something. What are you going to put in there? What's the base?
8.
8. What's the exponent?
1.
What's the argument that it equals? 7x squared minus x. Now we're getting into the possible extra credit. What are we going to do with this 8?
Move it.
We're going to move it. We're going to subtract it over to the other side. Well, folks, there's only one way to do this. And this takes us back to the quadratic chapter, which is why this might be an extra credit. I should be able to expect you to do everything to this point. If I had you leave your answer in this quadratic form, I'd probably give you extra, or I'll give you the full credit. Maybe I should just change this question and say, get it to exponential form. So for full credit, I'd probably say, get it to exponential form. If you want to get the real answers, that's where we could get the extra credit. So how does this factor? Walk me through that if you can remember that. We could do the Berry method, right?
Yeah.
That's how we handled these that did not have a 1 in front. So we would multiply there, and we'd have x squared minus x minus 56. And then we would sit there and say, okay, what multiplies together to give us 56? We know we got to have one positive and one negative. What multiplies together to give us 56, but it's only 1 unit away from each other? 7 and 8, right? The 8 would have to go with the negative so that we could get a negative x in the middle. And then what did we do after we got it factored? What came back?
7.
The 7 came back in front of both of the x's. And then we looked for GCFs we could pull out and get rid of. Does the first one have any GCFs you could pull out and get rid of?
Yeah.
What? Yes. 7x plus 7 does have a GCF. What can we go pull out and get rid of? 7, which would leave us with x plus
7.
1. if you took the 7 out, right?
Yeah. It was,
Does the other one have a GCF? No. Okay. So now what would we do? Set each factor equal to 0? And solve. What do you get?
-1
-1.
plus 8.
And then you'd add the 8, right? And you divide by the 7, and so that would be x equals 8 over 7. Now, this would definitely, I think, like I said, if you could get me to there, above that line, you would get the full credit. If you could go the distance, you'd be getting some extra credit on this question. Now, I also said something a few seconds ago about negative numbers. What did I say about negative numbers? You can't have them in a logarithm. So, that one doesn't even exist. Like I said, above the blue line would be what I'm expecting. Below would be a lot of extra work that we haven't done in a while. I think this one would may or may not be worse. That one's probably easier than the last one, quite honestly, because I don't think you'd have to use the Berry method at all. So we would have to FOIL this one times this one. So we'd have log base 2 of, let's see, if I multiply those together, what am I going to get? X squared, good call.
Minus 6x.
Minus 6x and a positive 1x. What do those add up to? That's a negative 5x. And then 1 times negative 6 gives me negative 6. Yeah, this is probably easier than the last one because we won't have to use the Berry method. So rewrite it in its other form. What's the base? 2. What's the exponent? 3. And it's equal to that other side, x squared minus 5x minus 6. And so this 2 to the third is 8. If we move it to the other side, we would get something like this. X squared minus 5x minus 14. And we could factor this one. I'm sure this one factors a little bit nicer than the last one. Minus 7 and plus 2. We didn't have to do any Berry method stuff. We could think of our basic normal factoring. Things that multiply together to give us 14, whose difference is negative 5. So what are the two possible answers?
7 and -2.
And what do we know about the negative 2? It can't be a good answer. 7 is the only one that works. If you don't believe me, go back and try to plug in a negative number into that logarithm expression up there, and you'll find out it doesn't work at all. So probably won't have a ton of these where you have to do a lot of factoring, okay? Probably won't throw a lot of those in. This one's actually easier than you think. Tell me what you know about this one. You've got a logarithm on both sides. They're both base 6. Can you tell me what you know about x plus 2? Come on, look at it. Nope.
Turn into
What?
equals -2.
No. Okay, look here. We have a logarithm base 6 on this side and a logarithm base 6 on this side. And right here, we are guaranteed that these are equal.
Cancel.
What do you know about x plus 2?
Cancel.
It equals 13.
Yeah, it equals 13.
Yeah.
Went along with that idea you were thinking of canceling. I like that thought. The arguments have to be identical. We see that the bases are the same. There's only one way that those two logarithms can be equal, and that's if the arguments are the same. So this is a super easy question. 11. That'll definitely, the one like that'll definitely be on there. Okay. What about this one? What can we do with these two? Multiply them together. Okay, so if we do that, that would be log 15x. So we've got this log equals this log. Tell me what you know about x plus 15. It equals 15x. Solve it. One of the x's over. That gave me 14x's equals 15. Now what? Divide by 14. So, there's my answer, 15 over 14. So we got a single logarithm on the right side, and then compared the arguments together, set them equal to each other, and solved. That's a pretty reasonable test question. We're going to be stopping around question 22. So from there on down, you can pretty much ignore it. Okay? We're just going to be running out of time here.
What is the test?
Test is the real deal test is Friday. Okay, so we're going to be doing a practice test tomorrow and correcting it and finishing it up Thursday. If we get time, we'll start our test Thursday, and then all Friday we'll finish our test.
Are we gonna work as teams for the practice test?
Yeah, you can work together on the practice. Sure. And use notes and things like that. But okay, as long as you actually work, you know what I'm saying.
Yeah.
Okay. So what do we do with the x plus 2 and the 9? We multiply them together, right? So that would give me log what? 9x plus 18. So what do we know about 8x minus 4? 9x plus 18. Okay, so this seems like it's becoming a broken record. That'd be 1x. That'd be, let's see, subtracting 18 gives me negative 22. Ooh. What'd we say? Come on, Mr. Barton, I heard it. Ah, look at this one. If negative 22 is my only option, that's not working for me. If you go back and plug that in here, negative 22 plus 2 is negative 20. You can't take the log of a negative number. We're done. There is no solution to that one. Okay? Is the left side of this equal to a single logarithm? Is this a single logarithm? No. So how do we make it a single logarithm? Move the 3. Thank you very much. So now we have log x cubed equals log 64. So, okay, so x cubed equals 64. We took the cube root on both sides, as all of you did in this classroom, because you understand how to solve those, and that's how we got 4. Question 21. What would you be doing over here? Dividing. Thank you very much. Appreciate that. A few of you said that. So that would be log of what?
X plus 13.
Okay.
2.
X plus. Whoa, that's terrible looking.
Over 2.
Yeah. That 13 got clapped. Okay, so. Hey, it's just this way it is, man. Sorry. 4x plus 2. What do we know about these two? The x plus 13 over 2. What do we know about it? It equals 4x plus 2. Okie dokie. Oops, sorry, not over x. What am I thinking? It is over 1, though. How do we handle proportions, folks? Cross multiply, okay? So when you get these proportion situations, make sure you cross multiply. So that would be 8x, right? 8x plus 4 equals x plus 13. We can push this over here, creating 7x. And we can push this over here, creating 9. What's my final answer going to be? 9 over 7. Okay, 9 over 7. So that was interesting. We used the division property first, and then had to set the two arguments equal to each other. Last question is a multiplication question. It's very similar to ones we've done before, so I don't think we really need to do that one. So we'll end on question 21 here. Those are the questions that you'll be required to know. As I said below, the other ones we will not worry about for this particular test.